Hi, we would like to share our recent work, a unified framework for event-based frame interpolation with ad-hoc deblurring in the wild. This work is mainly done in the robotics and perception group. When video frame interpolation methods are applied to blurry videos, they often struggle to handle the blurriness and are prone to producing artifacts. This issue arises primarily because these methods assume the video frames are sharp and fail to account for the effects of exposure time. Different from traditional frame-based camera, event cameras outputs asynchronous events with high temporal resolution, which is suitable for frame interpolation. For video frames, exposure time is the key factor. The length of the exposure time often influences the quality of the video. Videos with short exposure times typically have sharp images, while longer exposure times can cause frames to appear blurred due to motion occurring during the exposure period. Previous event-based frame interpolation methods have focused solely on either event-based sharp frame interpolation or event-based blurry frame interpolation. In this work, we define these two tasks as general event-based frame interpolation, and propose refid to handles both tasks using a single model. The proposed refid is shown here. Two reference images and corresponding events serve as the input of image branch. Events for the whole time range serve as the input for event branch. Given the two reference frame and the corresponding events, we can get the target frame from both forward and backward directions. Abstract from the equation, we design bidirectional event recurrent blocks. For a target frame, both the information in the past and the information in the future are utilized. All the events are converted to the voxel grid, and in each iteration, two-channel subvoxel with timestamps near the latent sharp frame are fed to the event branch to indicate the latent frame. To fuse the features from the event branch and image branch, as well as the features from the two reference images, we propose event-guided adaptive channel attention. Features from the events, which indicate the time, are used to determine the weights of features from the two consecutive images. Additionally, multi-head attention from the vanilla transformer is replaced by simple channel attention for efficiency. To test the performance of our method and bring the community with high-quality event-based dataset, we collected HighREV dataset, which consists of 30 sequences, more than 20,000 sharp frames and corresponding events, with a resolution of 1632 by 1224. The table shows the quantitative results of blurry frame interpolating on GoPro dataset with synthetic events and HighREV dataset with real events. 11+1 and 11+3 represents the blurry image is synthesized from 11 sharp images and skip 1 sharp image or 3 sharp images, respectively. Our method outperforms all the other methods in both dataset and both settings with at least 1.29 dB improvement. In sharp frame interpolation, our method also outperformed other event-based and image-only method like TimeLens on both synthetic dataset and real-world dataset. Further, our method can also deblur single image. Experiments on GoPro dataset and RE-blur dataset show that our method outperformed former SOTA method like EFNet. This slide shows some qualitative results on blurry frame interpolation. Compared with other methods, our refid shows less artifacts. In the comparison with frame-based method HighREV, our method deblurs each frame and produce natural high FPS video. In sharp frame interpolation task, our method also outperforms other methods with less artifacts and better consistency. By utilizing the event information effectively, our result shows less artifacts. When testing the model in real-world scenarios, the camera settings during training and testing are not perfectly aligned. This inconsistency can lead to poorer results during real-world testing. This domain gap is a significant factor affecting the performance of our algorithm in practical applications. Collecting paired ground truth images for training is impractical. Therefore, we propose a self-supervised fine-tuning framework for blurry frame interpolation and single-image deblurring. Without ground truth, our model can be fine-tuned on real-world blurry images. The initial supervised framework of refid is shown in the figure. Ground truth is utilized for supervised training. We cancel the ground truth and design the loss function using alternative constraints. The first one is blur consistency loss. Our refid predicts multiple frames, or short video clip, and the average of the predicted image sequence should be equal to the input blurry frame. Second, brightness increment loss. The event is triggered once the brightness changes overpasses the threshold. Hence, for the predicted frames, Their intensity changes should be equal to the event threshold. Finally, the warping loss. With the optical flow from event-based flow estimation module, we can warp the predicted frame to last timestamp and compare it with the corresponding predicted frame. This loss ensures the spatial consistency of the results. With the proposed self-supervised fine-tuning framework, our model trained on synthetic data can be fine-tuned on real-world blurry data without ground truth, which is easy to collect. This figure shows qualitative results from our method and other methods. After fine-tuning on real-world data, our method performs significantly better than the version without fine-tuning. Compared to other self-supervised learning methods, our approach is more robust to noise and can effectively mitigate the degradation caused by noise accumulation. In this work, we unified event-based sharp frame interpolation and blurry frame interpolation. Secondly, we proposed refid, an event-based frame interpolation framework with ad-hoc deblurring. Then, a self-supervised fine-tuning framework is introduced to adapt the pre-trained model to real-world data. Finally, we captured a new high-resolution real-world dataset for event-based video deblurring and event-based frame interpolation. Thank you for your attention.